Welcome to a new test and teardown video. This time it's an Eico 378 audio generator, all tube based from about 1965. And I am super excited about this one, and there's a few reasons for that. Please, if you did not see my video from yesterday, I've been playing around all day with the Heathkit IG-72. And if you compare the layout and the features and everything with the Heathkit, this one is exactly the same. And what do you know? This one is using exactly the same tubes as well. So let's open and see if it is exactly the same inside. Somebody stole a design from somebody. I don't know who stole what from who, or how are they related, or what is going on, but this one is a lot more heavy. It's also a lot better. I mean, the casing and everything here is really nice and stable. It's not the same flimsy metal the Heathkit they're always made of. But yeah, let's open and inspect. I think it is very, very fascinating and interesting to have a little look inside this Eico. It is exactly the same content. We got the two switches that's doing exactly the same. The potmeter for the variable output. We got the rectifier tube here. This is the 6X6. Then we got the 6CL6, and then we got the 6AU6. Very, very classic tubes. And of course, we got the little bulb for the oscillator level, and exactly the same two trimmers for the feedback and the meter calibrations. And the whole design of this, with this bracket that's bent and all that, and the way that this is screwed to the front and all that, it's exactly the same idea as the Heathkit. It's super interesting to see how well this one compares to the Heathkit. Again, we got exactly the same setup with this coil between the two capacitors and the rectifier tube and all that. That is exactly the same. Also, the power resistors and the two tubes here and the feedback system with those capacitors and this bulb, and the way that everything here is the same. I definitely would say that this is the same schematic. We also got the multiplier here with all the capacitors, and we got the two frequency settings with resistors exactly the same way. We can even see the diodes here for the meter. This is exactly the same circuit with the 3 diodes, and those 2 resistors to ground. That's exactly the same values as well. I can just remember this in my head because I played with the other one yesterday. And this one has been serviced a little bit. You can see nice new capacitors, nice new resistors, and a lot of stuff was changed. And I wonder what happened here, because some large power resistor blew up big time in this area. How about that? A nasty meltdown. So that is why everything here is nice and new. Also up here we got some remains after a little meltdown explosion. So I think we should definitely power this up and play with it. So like that. And it's using 20 watts. That is not so much. Of course, it needs to warm up a little bit, and then it's probably gonna get a lot more, right? Oh, we got little bit. Okay, this one needs a little bit of a cleaning. But it seems to be really nice. So this is 550 Hertz. Let's see, times 10, 5, and 5. So that is pretty good, isn't it? So if I give this one more, it is 559 Hertz. This one is really accurate. So this is 5.5 kilohertz, and it can also do, yeah, 57 kilohertz. Oh, look, it's a little bit. What? Where is this instability here? Oh, there's a little bit of microphonics. Maybe it's this put, yeah, see? There's a little bit of instability, and maybe that has something to do with mains frequency. If we go down here in the milliseconds, we can probably see there's a little bit of ripple. So that is probably what we got. But now we want to test the lowest. Boing. Don't you just love it? Every time you change frequency, it goes like that. So times 1 is, oi, oi, oi. Let's go real slow here. So this is 55 Hertz. And here you can definitely see the mains frequency is affecting the output, right? It's probably going to be even worse if I dial this down to exactly 50. Yeah. Then it's going to go. Oh, we need to. Then it will beat with the mains frequency like that, and it will go pretty unstable. This is definitely what I expected, but it's probably going to go. It's going to go a little bit more away. The further we go away from mains frequency, it's probably going to stabilize us here. There's a very long stabilize when it's running real slow. See, now it's completely stable here at 30 Hertz. But we can of course go all the way to 1, probably. And then look at the meter here. Isn't that just nice? Okay, then it stops completely at 0, 0. That is of course 0 Hertz. But it can do 1. This is a little bit more than 1, isn't it? But anyway, this fantastic thing is definitely working. I'm super excited about that. But I think this is really a super short video about a super clone of another product. So who cloned who? I don't know. Maybe somebody knows more. Maybe you can Google. Have you got some information? Then try and share this. Give me some comments on who copied who. That could be quite interesting. Or maybe they are, I don't know, they joined forces or something like that, right? So thank you very much for watching. I hope to see you soon again. Bye bye.